Hello, welcome everyone. Question says if you know the wavelength corresponding to peak radiation. It says peak radiation. So emitted from the start 418 nanometer. Temperature of surface. Consider the star radius as a black body. So it says calculate the temperature and black body. It says black body. We have a formula for the black body radiation, and it says peak, that means maximum. Lambda max times T is equal a constant value 0.2898 times 10 to minus 2 meter times Kelvin. And question says what's the temperature? Temperature is going to be 0.2898 times 10 to minus 2 over lambda max. Lambda max given 480 nanometer. Nano means 10 to minus 9. So the result going to be 6037.5 Kelvin. Thanks for watching. Hello, welcome everyone. Question says assume that Planck constant 66 and the mass 80 and speed 1.1, and what is the de Broglie wavelength? And de Broglie wavelength is equal h over mv, and this question h, that means Planck constant given 66 over m is 80 times speed 1.1, and it's equal 0.75 meters. Thanks for watching. Hello, welcome everyone. Question says given photon wavelength 3 nanometers, calculate its momentum. Lambda equal h over p, that means Planck constant over momentum. So momentum is equal h over lambda. H is a Planck constant, which is 6.63 times 10 to minus 34 over lambda is 3 nanometer. Nanometer is 10 to minus 9. So momentum is going to be 2.21 times 10 to minus 25 kilogram meter per second. Thanks for watching. Hello, welcome everyone. Question says light with wavelength 300 nanometer fell on the surface. If the actual wavelength for this metal 500 nanometers, find the stopping potential. That means question asks what is the stopping potential in order the photoelectron emitted with maximum kinetic energy. And this given to calculate work function. Work function is equal h times f. And kinetic energy formula is equal HF minus work function and the kinetic energy max equal EVS. When we calculate kinetic energy, that kinetic energy is going to equal kinetic energy max. So we have to calculate first of all the frequency, because in the formulas we have frequency. The frequency of wavelength c over lambda. C is the speed of light 3 times 10 to the power of 8 over 300 times 10 to the power of minus 9. So it's going to be 10 to 15 hertz. And we have to calculate this wavelength for the threshold frequency. Let's say this one f0 is equal c over lambda 0, let's say 3 times 10 to the power of 8 over 500 nanometer, 500 times 10 to the power of minus 9. So it's going to be 0.6 times 10 to the power of 15 hertz. Now I can use this formula to calculate kinetic energy. Kinetic energy equal H times F minus F0, because phi is equal to H times F0. We have common factor, so H times F is 10 to 15 minus 0.6 times 10 to 15. Result of this one going to be 0.4 times 10 to 15, and the Planck constant 6.63 times 10 to minus 34 times 0.4 times 10 to 15, and this will be equal 2.652 times 10 to minus 19 joule, and Ke equal EVS, and E is the charge of electron 1.6 times 10 to the power of negative 19 times Vs equal this value 2.652 times 10 to minus 19, and 10 to minus 19, 10 to minus 19 going to cancel each other. Vs equal 2.652 over 1.6. The result going to be 1.652 volt. Thanks for watching. Hello, welcome everyone. Question says, photoelectrons stop emitting when the wavelength 600 nanometer. That means this is the cutoff wavelength. And when the metal surface lightened by the wavelength of 300 nanometer. What's the kinetic energy of the maximum in which the electron emits from the surface of the metal in joule and electron volt? And first let's calculate the frequency. Cutoff frequency equal C over cutoff wavelength. 3 times 10 to the power of 8 over 600 times 10 to the power of minus 9. And it's going to be equal 0.5 times 10 to 15 Hertz. And kinetic energy max equal HF minus work function or HF minus H times cutoff frequency. So H is the common factor, F minus FC. And we have to calculate F, by the way. F equal C over lambda. C is 3 times 10 to the power of 8 over 300 times 10 to the power of minus 9. That's 300 nanometer. So it's going to be 10 to 15 Hertz. So Ki max going to be H is the 6.63 times 10 to the power of minus negative 34 10 to 15 minus 0.5 times 10 to 15. So it's going to be the result of this part is going to be 0.5 times 10 to 15. So 6.63 times 0.5 it's going to be 3.32 times 10 to 15 times 10 to minus 34. It's going to be 10 to negative 19. The unit going to be joule. And question says also in electron volt EV, electron volt 1 electron volt equal 1.6 times 10 to negative 19 joule. So to convert it to electron volt, we have to divide it to 1.6 times 10 to negative 19. So 3.32 times 10 to negative 19 times 1 EV over 1.6 times 10 to negative 19. Ten to negative 19. And 10 to negative 19 and 10 to negative 19 going to cancel each other. The result going to be 2.075 electron volt. Thanks for watching. Hello, welcome everyone. Question says light wavelength 10 to minus 7 meter and the work function 1.67 times 10 to minus 19 joule. Find maximum speed for the photoelectrons emitted from the surface of metal. And how can we find the maximum speed? From the formula of Ke max. Ke max is equal half mv squared, and also Ke max equal hf minus work function. So we have to calculate f, and f equal c over lambda 3 times 10 to 8 over 10 to minus 7. It's going to be 3 times 10 to minus 15 hertz. So h is 6.63 times 10 to minus 34 times 3 times 10 to minus 15, which is f, minus work function equal 1.67 times 10 to negative 19. Ke max going to be equal 18.22 times 10 to minus 19 joule, and the Ke max equal half mv square, and m is the mass of electron, because it says electron, and mass of electron is constant, and v is the maximum speed of the electron. So 2 Ke max equal mv squared. So v squared equal 2 Ke max over m, and the v equal, if we take the square root of both sides, v going to be 2 Ke max over m in root 2 times Ke max, we calculated 18.22 times 10 to minus negative 19 over m is the mass of electron, 9.11 times 10 to minus 31, and the result going to be 2 times 10 to 6 meter per second. This solution for the A, and for the B says de Broglie wavelength for the maximum speed, and the de Broglie wavelength formula, lambda is equal h over mv, h 6.63 times 10 to minus 34 over m, 9.11 times 10 to minus 31, and v, as we calculate, 2 times 10 to 6, and the result going to be 0.364 times 10 to minus 9 meter. Thanks for watching. Hello, welcome everyone. Question says light frequency zero point 0.6 times 10 to 15 Hz fall on the surface of metal. Stopping potential 0.18 volt. And another light fell on the same metal has frequency 1.6 times 10 to 15 and its stopping potential equal 4.324 volt. Find the value of Planck's constant. That means the question says what is the H? It's like proof. And Ke max equal HF minus work function. And also Ke max equal EVS. Vs means stopping potential. So HF minus phi going to be equal EVS. And we have two information about the same metal. So we are going to obtain two equation. The first equation going to be first one HF H first frequency, let's say minus phi equal EVS first stopping potential, and the second one H times F2 second frequency minus work function. Why we are saying, we are not saying actually first work function and second work function, because we are talking about the same metal, so it's going to be same work function equal EVS2. And we have two equation F1 F2 E and this E VS1 and VS2 known information, and the H unknown. It's asking, we're going to try to find it, and also phi missing, there is no any information about it. We have to multiply this with the negative, so we have to add them to each other, and it's going to be H F2 minus H F1, and this is going to be plus and this is negative, so this and this going to cancel each other, so equal EVS2 minus EVS1, and there is a common factor H equal H parenthesis F2 minus F1 equal, also there is common factor EVS2 minus VS1. So H going to be from the cross multiplication E parenthesis VS2 minus VS1 over F2 minus F1. And what are we going to do? We're going to substitute value H equal E 1.6 times 10 to negative 19 parenthesis VS2, this is VS2 4.324 minus VS1 0.18 over F2 is 1.6 times 10 to 15 minus 0.6 times 10 to 15, and 10 to 15 and 10 to 15 is the common factor, so when we subtract 1.6 minus 0.6 it will be 1. So H going to be, if you do this operation with the calculator or by yourself, it's going to take a time 6.63 times 10 to negative 34. Thanks for watching. Hello, welcome everyone. Question says find the length de Broglie wave. That means de Broglie wave is equal h over lambda equal h over mv. And from in this equation, h is constant, m is constant. I need only v, which is speed. And in the equation, it says electron accelerated during the potential difference 100 volt. That means kinetic energy equal potential energy. The kinetic energy formula half m v squared. This is the speed equal potential energy E times v potential difference. And it's going to be from the cross multiplication m v squared equal 2 ev divided by both sides m and to take the square root of both sides. So v, which is speed, going to be equal to ev over m in a square root. So let's substitute the value of them. 2 times is 1.6 times 10 to minus 19, v is 100 over m is the mass of electron, 9.11 times 10 to minus 31 in a root, and v going to be the speed of the electron going to be 5.927 times 10 to 6 meter per second. And now we can substitute the v in this formula. H, as you know, 6.63 times 10 to minus 34 over mass of electron, 9.11 times 10 to minus 31 times speed 5.927 times 10 to 6, and the lambda, which is the Broglie wavelength, going to be 0.123 times 10 to minus 9 meters, or 0.123 nanometer, we can say. Thanks for watching. Hello, welcome everyone. Question says electron moves with the speed 663 meter per second. A. Calculate the de Broglie wavelength. De Broglie wavelength is equal h over mv. H is the Planck constant 6.63 times 10 to the power of minus 34 over m is the mass of electron, 9.11 times 10 to minus 31 times v is given 663. So the wavelength going to be 1.098 times 10 to minus 6 meter. This is the solution for the A. And for the B, it says the least error. We have two formula about this uncertainty of the uncertainty principle, and this one says the least. So if it says the least, delta x times delta b going to be equal h over 4 pi. We must use this one. And there is an information to if the error in its speed 0.05%, and find the error, find the location, electron location, the error in the location. So delta v equal 0.05 over 100 times 663. It's going to give us delta v 0.3315, and delta p equals m times delta v, as you know. So from the formula, delta x equal h over delta p times 4 pi, and the delta p equal m times delta v times 4 pi. When we substitute their value, h is the 6.63 times 10 to minus 34. M is the mass of electron, 9.11 times 10 to minus 31 times delta V, as we calculate, 0.3315 times 4 times pi, 3.14, and the delta x going to be 1.748 times 10 to minus 4 meter. Thanks for watching. Hello, welcome everyone. Question says proton with a kinetic energy 1.6 times 10 to minus 13 joule. Uncertainty of its momentum given 5% from its original momentum. What's the least uncertainty of its location, where the mass of proton is given? Okay, so we have to calculate delta x, and the delta x equal, we have to use the sign of equal, h over 4 pi, but we are going to send there delta p times 4 pi. We are going to use this formula, but we have to calculate momentum. How can we calculate momentum? Kinetic energy given, kinetic energy formula is half m v squared, and the formula of momentum, as you know, is the m times v. So if I multiply by this with the m, and if I divide with the m, so it's going to be m squared times v squared over 2m. That means m times v is the p, so it will be p squared over 2m equal kinetic energy. And from there, p squared going to be equal 2m, which is mass, ke, take the square root of both sides, p going to be equal to m ke in a root, square root. So when we substitute their value, we are going to calculate p. and kinetic energy 1.6 times 10 to minus 13 times 2 times m mass of proton 1.67 times 10 to minus 27, so the very long root. So the result going to be 2.312 times 10 to minus 20. And we calculate the momentum. Now we have to find delta P. Delta P is equal 5% of it times 2.312 times 10 to minus 20, and it's going to be equal 0.1156 times 10 to minus 20. So we can calculate the delta x now. H over delta P times 4 pi. H 6.63 times 10 to the power of minus 34 over delta P 0.11, this is the point, 56 times 10 to minus 20 times 4 times 3.14, and it will be equal 4.566 times 10 to minus 14 meters. Thanks for watching. Hello, welcome everyone. Question says find the speed of an electron associated to de Broglie wavelength and the frequency given. And de Broglie wavelength lambda equals h over mv. From the cross multiplication, lambda and v position going to change. V equal h over m times lambda. By the way, lambda equal c over f, as you know. We are going to substitute it in this equation. V will be equal h over m times c over frequency. So it will be h times f over m times c. This is the formula of velocity. So V equal h times f over mc. H Planck constant 6.63 times 10 to the power of minus 34 times f is given 3.25 times 10 to 17 over mass, and it says electron, so electron mass 9.11 times 10 to minus 31, and the c is the speed of light 3 times 10 to 8, which is accepted value of it. So the result going to be 7.88 times 10 to 5 meter per second. Thanks for watching. Hello, welcome everyone. Question says suppose uncertainty in a particle's location, mass m, speed v equal de Broglie. That means delta x is equals to de Broglie wavelength. De Broglie wavelength is equals to h over mv. Prove that delta v over v equal 1 over 4 pi, where delta v equal uncertainty in the particle speed. The formula of uncertainty principle, delta x times delta p equal h over 4 pi. And as you know, delta p equal m times delta v, and delta x equal h over mv, because it says that. Now I'm going to substitute them. Instead of delta x, h over mv, times instead of delta p, m times delta v equal h over 4 pi. And h and h going to cancel each other. M and m going to cancel each other. We have delta v over v. Delta v over v equal, there is nothing, that means 1 over 4 pi. That's all. Thanks for watching.